Did you know stars are born in massive clouds of gas and dust called nebulas? These nebulas are often the remnants of previous stars that have exploded in supernovae, scattering their material across the cosmos. Over millions of years, these clouds of gas and dust begin to collapse under their own gravity, creating regions of higher density. These regions are the birthplaces of new stars. Gravity pulls this material together, forming a dense core called a protostar. As the core contracts, it heats up, and the temperature in the center of the protostar rises. When the core temperature becomes high enough, nuclear fusion reactions begin. This process converts hydrogen into helium, releasing a tremendous amount of energy. When nuclear fusion ignites, a star is born. This marks the beginning of the star's main sequence phase, where it will spend the majority of its life. During this phase, the star is in a state of hydrostatic equilibrium, with the outward pressure from nuclear fusion balancing the inward pull of gravity. Stars spend most of their lives fusing hydrogen into helium. This process occurs in the core of the star, where temperatures and pressures are incredibly high. The energy produced by fusion radiates outward, providing the light and heat that we see from Earth. The length of time a star spends in this phase depends on its mass. More massive stars burn through their fuel much faster than smaller stars, but what happens when they run out of fuel? As a star exhausts its hydrogen supply, the core contracts and heats up, causing the outer layers to expand. This leads to the next phase in a star's life cycle. Smaller stars like our Sun expand into red giants and shed their outer layers, creating beautiful planetary nebulas. The core that remains is no longer able to sustain nuclear fusion reactions, leaving behind a white dwarf. This white dwarf is incredibly dense, with a mass comparable to the Sun, but a volume similar to Earth. Over billions of years it will cool and fade away. Massive stars end their lives in spectacular supernova explosions, which are some of the most energetic events in the universe. These explosions occur when the core of the star collapses under gravity, triggering a massive release of energy, scattering elements across the cosmos. These elements, such as carbon, oxygen, and iron, are essential for the formation of planets and life. In fact, the very atoms in our bodies were forged in the hearts of stars and scattered by supernovae. Their remnants become neutron stars or black holes, the universe's ultimate recycling centers. Neutron stars are incredibly dense, with a mass greater than the Sun, but a diameter of only about 20 kilometers. Black holes, on the other hand, have such strong gravitational fields that not even light can escape from them. Want more cosmic facts? Like and subscribe for more. Join us as we continue to explore the wonders of the universe, from the smallest particles to the largest galaxies.